Okay, guys, so thank you for coming. This is the first live session for DWSIM. I'm going to teach you how to code a unit operation, and we will be doing this slowly so you can follow me. If you have some questions, you can put it on the chat. We will stop and help you. You can ask in English, ou você pode perguntar em português também, or in Spanish. We don't have to follow any strict rules. We will do everything really slow so you can learn how to code a unit operation and compile a library and use that library in the DWSIM, okay? So let's begin with a small introduction about what we are going to do today, okay? Okay. Okay, so I believe that you have installed Visual Studio 2019 already, and if you don't have time anymore because it takes a lot of time. You have to install the .NET 4.6.2 targeting pack too, because the DWSIM is compiled targeting this. Okay, guys, so thank you for coming. This is the first live session for the DWSIM. I'm going to teach you how to code a unit operation, and we will be doing this slowly so you can follow me. If you have some questions, you can put it on the chat. We will stop and help you. You can ask in English, ou você pode perguntar em português também, or in Spanish. We don't have to follow any strict rules. We will do everything really slow so you can learn how to code a unit operation and compile a library and use that library in the DWSIM, okay? So let's begin with a small introduction about what we are going to do today, okay? Okay. Okay, so I believe that you have installed Visual Studio 2019 already, and if you don't have time anymore because it takes a lot of time. You have to install the .NET 4.6.2 targeting pack too, because the DWSIM is compiled targeting this specific version of the .NET framework. And you also need to install the DWSIM 6.4.4 or 0.5, which was released yesterday. You don't have to download the source code because we are not going to play with the source, only with the compiled libraries for the DWSIM, okay? So what is a unit operation? I got this text from Wikipedia. So in chemical engineering and related fields, a unit operation is a basic step in the process. Unit operations involve a physical change or chemical transformation, such as separation, crystallization, evaporation, blah, 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 blah. But in a process simulator, we have a unit operation is a single flowsheet block object, I like to call it object too, which performs material and energy balances, reading information from inlet streams, and writing the results to outlet streams. Some simulators can do this backwards. They can get information from the outlet streams and write back and solve everything at once, but the DWSIM does not do this yet, but hopefully it will do it someday. Okay, in this image, you can see an object for a gas compression unit operation with one inlet material stream, one inlet energy stream, which represents the power source of the compression, and one outlet stream, which is the compressed gas. Okay, I think you are all familiar with this stuff, but it is important to introduce the concepts for those who are not. So what is a unit operation model in DWSIM? All unit operations are located in a single library, which is DWSIM.unitoperations.dll, but you can also add external unit operations in other dynamic link libraries, the DLLs, and they are loaded by DWSIM during the startup, okay? And these libraries must implement a specific interface so the DWSIM can understand that that object is a unit operation and load it in the flow sheet and make it available for you to add into the flow sheet. So for those who are not familiar with object-oriented programming, an interface defines a contract between two objects with some predefined rules. So an interface contains definitions for functions and properties that must be implemented so the objects can communicate with each other and exchange information. Today we are going to create a simple humidifier unit operation. Humidification is an operation that consists of increasing the amount of vapor present in a gaseous current, your stream, and the vapor can increase by increase its humidity. It was missing it. By passing the gas through a liquid that evaporates in the gas. So we will have a stream containing water, liquid water, and another stream with a gas stream, and they are going to be mixed together, and they can be mixed and exit the unit operation in a single stream, or we can separate these streams just in case we add more water than needed. We are going to do the both ways. I'm going to teach you how to do it. Okay. So now let's go to the actual work. So what's the first step to create a unit operation for the DWSIM? We are going to create a new Visual Basic class library in Visual Studio. So let's go. Let's open Visual Studio. Just a minute. Let's start. Yeah, that's right. I was choosing the one. Yeah, because they are pushing us to the newer versions. Yeah, this is the one. Oh, you don't use that. Yeah, that. You can put any name if you want. Yes, I like to write it this way because it makes easier to know what the library is and what it contains. I believe some people is reporting a lag. I'm going to change my internet here. Just a minute. I'll be back. And browse this project in there. Okay. Okay, so now we are going to add references to the DWSIM libraries. You must click on reference, on add reference. And then we go to browse. And we must locate the folder where DWSIM is installed. here in my computer, I have it on app data, local, DWSIM 6. And so we need to add references to KP Open. And drawing skill sharp, drawing point, extension methods, global settings, interfaces, shared classes, thermodynamics, obviously, unit operations, which one? Newton's of JSON, skill sharp extended, views desktop common, views Windows Forms. Let me see if there's something else. Okay, docking library, because the editor for the unit operation must reference this library. Okay, so we can add and okay, and all these libraries will be added as a reference to our library. So we must, by default, they are added with the copy local setting to true, indicating that this reference will be copied to the output directory, but we don't need that because we don't need to copy all these libraries again to the DWSIM directory, so we will select all of them. And we are going to set copy local to false. No, that didn't work as expected. Are you seeing my Visual Studio window?
Yes.
Yes, we do.
Yes, we can see it, yeah.
So did you add the references already? These ones?
Could you review the reference setup, please?
Are these ones, these ones which are selected here? You can find these. Yeah, you can find these libraries in the DWSIM directory.
Okay. Okay, great. Thank you.
Then after adding them, you must set copy local to false for all of them. And don't forget to save the solution.
Okay.
Next step is to rename the class. You can select and press F2 and type Humidifier, because this will be our unit operation class. And you can see that it already renamed it here too. Can I proceed, or are you still adding the reference?
Yes, you may proceed. Don't worry.
Yeah, proceed.
Okay,
Just a single question. By the way, you added the CapeOpen DLL. So is this going to be a CapeOpen compatible unit operation?
No, but it's just because my base class, unit operation class, depends on this library. We need to add a reference to it. But I'm thinking about teaching you to create a CapeOpen library later. But before we learn to create a CapeOpen library, we must learn how to do a property package, because I promised it on LinkedIn. So to create a CapeOpen unit operation, it is a little bit more complicated. We have to be more careful, so it can take a little bit more time. But we can do it in Visual Studio too, using the same environment. We don't need anything special. It's just because CapeOpen is more difficult for you to get properties from streams, and you need to write the properties to the outlet streams in a very specific way. The DWSIM is more flexible in this matter. Okay, so next we must indicate that this class, the humidifier, inherits from our base unit operation class in DWSIM. Oh, not in the, it is on shared classes. Shared classes, unit operations, base class. Okay. By doing this and pressing enter, we tell DWSIM that this class inherits all properties from the base unit operation class, so we don't need to write them again.
We are getting your background music.
Sorry? Are you hearing a background music, or do you want the background music?
No, I can hear you well. I don't hear any music.
No, I closed it because I think it was... I can put it back if you want. I personally, I love to do it, listening to music. So I'm going to put it a little... So you can see that it already added some procedures here.
Now there is loud music.
Yes, I'm going to... This is... I don't think it will work. The lowest volume is too loud for you. Let's proceed with that, please.
Okay.
Okay, so the first procedure tells the DWSIM that this unit operation can be used in the mobile versions, but we don't need this. So we can just return false here. I don't think this will work like this. We must do it like this, false. Okay. The second one, I'm going to add comments here so you can understand. If you can't hear me well, you'll be able to read. The second one is to display the editor on the classic user interface. We will need to do this. Update this, update the unit operation, the editor window. This routine is called when you solve the flow sheet and the DWSIM asks the editor to update its values. If we have any parameter that gets calculated by the flow sheet, and we need to update the editor so you can see that the properties change it. This one is to close. So this will press it. We need to implement all these functions. So by default, it adds this throw not implemented exception, but we need to work on them. Let's define two properties here. Private property name, name and string equal to humidifier. Private property description. This is the description of the unit operation. I'm going to add Humidifier Unit Operation. Yes. Okay. So in get display name, we return the value of your name, and on display description, we return the for description value. So for these are for cloning. When you select the unit operation on the flow sheet and you select clone, this function gets called, one of these. In the XML version, I think we missed a reference. We need to add a reference for the XML serializer. This one, I forgot to add it. Copy local false. I'm going to add two the get icon bitmap returns the image of our unit operation. I've already, I think that's on. I'm going to put the link for the folder in my Google Drive so you can get the icons and the presentation for this session. Just let me find it. I'm going to put it on the chat, okay? So I'll be opening the DWSIM there to show you what we are doing. Are you seeing the DWSIM?
Yeah, we can see it.
Yeah, okay. So what this function here does, get icon bitmap, it gets the image that is displayed here on the palette, I think. We must add something to be displayed here. So we must go to my project. In Visual Basic projects, this is much easier to do than on C#. And so we go to resources and add existing file. I have the icon already here, so you can also get it from the folder I've shared with you. I'm going to add these two because instead of drawing the object using vector, we will display the same image, but in a higher resolution, so we don't have to. It is really boring to write vectors to draw the object in the flowsheet, so we'll be displaying an image instead. It's much easier. I'm going to add these two images to my project. These two bitmaps. Save it. And here we return the first image. We can access it to my resources. Humidifier 32 pixels, the smaller version of the image. On clone XML, we can create a new version of the object using the XML serializer. New object equals to, oops, someone is trying to enter, Manuel Crespo. Bem-vindo, Manuel. Vamos lá. Let's go. Okay, so we can use the XML serializer here. And we will serialize this object, which we can reference it by me. In Visual Basic we use me. In C# is this. Okay. And what this function does, it gets every single property of this object and return a list of X elements, which is a list of XML elements. And actually this is not a new object, this is object data. And then we create a new object, equal to new. I get confused with C# sometimes. So as new humidifier. Okay. So this function must return a new humidifier with the same properties of this one that we are coding here. So what we are doing here is to get the data from this humidifier, supposing that we had this humidifier is added to the flow sheet, and we must return a new humidifier with the same properties. That's why we are serializing it to XML, and now we are going to load data, and the data is in the object data that we created before. I think let me know if you don't understand or if you are confused with my explanation.
Daniel? Sorry, it will be possible to get you will post a record of this video later?
Yes, yes, I am recording the video. So I will.
Right.
I'm going to edit and add to the YouTube channel. Okay, so this is okay. We are returning a new humidifier. And now we are going to do the same, but using JSON clone instead. We are going to get serialize the data of our object using the unitops library. Convert serialize object, which is me. Instead of returning a list of XML elements, this one returns a single string. It is a JSON object. Okay. And now we create a new humidifier. deserialize the data. Using this syntax of and passing the JSON string as a argument. You can see that this function returns a new humidifier because we put this here. And then we return new humidifier. Hello, Varun.
Yeah, eu tô.
I'm teaching how to create the unit operation here. I've already added the references. There is one reference that I forgot to add in the previous step, which is this one. And we create a new class here, the unit operation class. I renamed it to humidifier. And this class must inherit from the base unit operation class in the shared classes library in the DWSIM. And we are defining some functions here. To clone the object, we added 2 icons to our project, 2 images, 2 here, my project, and resources, add resource, add existing file. I've put the link to these images in the chat. You can open it if you want to do it. So we added these 2 images. This image here is the one that will get displayed here in the object palette. And the biggest one is the one that we will actually use to display the object in the flowsheet. Instead of drawing using vectors, we will display a single image because it is easier to work with. Okay. Okay, so now we are going to implement the interface that makes the DWSIM to recognize this unit operation as a external unit operation. Then we press enter, and it will create new functions here for us to implement. Okay, so let's go. This one asks for the name of the object, so we can return the same value, same property that we created. This one asks for the description. Same. Okay. This one is the prefix. I think it is prefix. Yes, Varun, I will upload the session. I'm recording it, and I will upload to YouTube as soon as possible. I will upload it today. So this prefix here is the one that gets added to the name of the object. So we will put, for instance, for material stream we have MSTR. For our humidifier, we can put something like this. What else we need here? Okay, return instance, where we must return a new instance of this unit operation. This is used when we are loading a new flowsheet in DWSIM. It calls this function to get a new object, a new humidifier. we can just put return new humidifier. Yeah, okay. These ones are very special. I'm going to add the comment for them so you can use function draws the object on the flow sheet. This function, this one creates the connection parts in the flow sheet object, and this one, this function display the add the properties on the cross-platform user interface. Hello, Musharraf.
Hi, good afternoon.
Good afternoon. Don't worry, I'm going to upload the video to YouTube later. You won't miss anything, okay?
Okay, thank you.
I'm currently implementing the required functions, but we didn't get to the actual model itself for the humidifier, okay? We are just implementing the required functions to display the object in the flow sheet and some other functions to get the object name and the description. And now I'm going to code the function to display the object in the flow sheet. Let me upload to GitHub just to not to lose anything. Okay, so now we are going to display the icon on the flow sheet to create the function to display the icon on the flow sheet. And for this, we need to create a new variable here, which is a skier sharp sk image. This image will hold the actual bitmap to draw to the flow sheet. So it is better to create an internal variable so we don't need to open and display the bitmap every single time the flow sheet gets drawn, because it will consume a lot of resources. So it is much safer and wiser to use an internal variable to hold the data for the bitmap in memory. So now we must get the canvas object, the skier sharp canvas, which is the flow sheet canvas itself. This white area is passed to this function as the G variable. So we must convert it to direct cast to a canvas, skier sharp canvas, sk canvas. I'm not going to add any imports here, because if I add imports to get the functions easier, you may get lost in the functions. You may not know where they are coming from. So it is better to type the full name of the classes and stuff, because I think it is better for you to see where they are coming from. Okay. So now we check if our image is already loaded. If image is nothing, then we draw it. We will do the following. I have some code here. Yes. So if our image is nothing, then we will use a bitmap. Here I'm going to need to add an import, so we can use an extension function from the skill shop views desktop extensions. We will need a extension function from this library here to convert the bitmap from a system drawing bitmap to a SK bitmap. Sorry. Yeah, I think this is correct. No, we must convert it to a SK bitmap. Okay, the bitmap here, which is a system drawing bitmap, we must convert it to a SK bitmap. And then this SK bitmap will be added to our SK image here. Image equals to SK image from our bitmap. Okay, so this will be called in the first draw of the flowsheet because our image will be nothing. Then we will load our image here, this one. We will load this image into this image object in memory. And now we are going to display this object in our flow sheet. When we have a object in the flow sheet, let me try to draw it for you. Okay. So when we have the flow sheet, our coordinate system, the coordinate system for the flow sheet starts from here. For instance, it starts from here actually, but we have, this is our y axis and this is our x. And every object has a initial coordinate here, and it has a width and a height. Okay, so every time we add an object to the flow sheet, it gets added into a specific x and y coordinate. And
I think you are using whiteboard. We cannot see it.
Sorry?
I can't see your typing.
Are
you typing?
I'm drawing into the screen. Let me. I think you are not seeing it.
Yeah, we cannot see the drawing.
Yeah, let me try to display the image.
La imagen sí se veía, Daniel.
Vocês estão vendo? Are you seeing it?
Yeah, now we can see
Yeah,
it.
can you see my drawing?
Sí, sí.
Yeah,
See?
now we can see it.
Okay, so I was telling that this is our coordinate system for the flow sheet. So we have an x-axis and our y-axis. And when you add an object to the flow sheet, it has its initial coordinate, which is this one, x and y, and it has a width and a height. Okay?
Yeah.
So when we implement the drawing function, we get its initial coordinate, which is the graphic object is a reference to our object in the flowsheet, because this one, we have two different objects to represent the unit operation. We have the unit operation itself, which is a model, which is stored in a different collection in the flowsheet, and we have the graphic objects in the flowsheet, which are just graphical representation of our object. So we can get the graphical representation of this unit operation through the graphic object variable, and it has a x, which is the x coordinate, and we have the y coordinate. And we have its width 2 and the height. Okay, so now what we must do is to draw the bitmap inside this box formed by the x coordinates and the width and the height. So this is how we are going to do it. We use a new SK paint. It's just like a pen with this property, which is called is anti-alias, I think. Anti-alias. This property, I think this one is needed because we are drawing an image. We just need to use this filter quality. Sorry, this filter quality property to high to draw our image using the highest quality possible. And now we tell the canvas to draw the image. We send the image as an argument, and this second argument are the coordinates of the flow sheet. So we send the coordinates as a new SK rectangle with the x and y and the width, and instead of asking for the width, it asks for the x2 coordinate, I think. I'm not sure why it's not working. Oh, okay, because of the sharp. Okay, I was missing this one. Yes, the 4 arguments for the SK rectangle are the left, top, right, and bottom coordinates. So left is the x, top is the y, right is the x plus the width of the object, and the bottom is the y coordinate plus the height of the object. And we send the paint, our pen, as the last argument. So this is enough for us to display the object in the flow sheet. Okay. I'm not sure if this is going to work right away. I think it is better to create the ports first. So I'm thinking about starting with our humidifier here, right? So we will have one inlet port for the gas and one inlet port for the water. Oof, this is terrible. I'm trying to draw in.
Okay.
Okay. Okay, I'm going to type there's the first gas. This one is the water. And we will be implementing only one outlet port. It's going to be the gas plus water. So we need two inlet ports and one outlet port. So let's remember our coordinate system. Okay. So we will need our coordinate system to set the position of this inlet port, these two, and the outlet port too. Okay. Let's go back. So The outlet ports are located in the graphic object. Inlet input connectors. So first we check if we have input connectors or not. If they are equal to 0, it is because we didn't create it and add them. So we need to create an add. So we are going to create a new important as new graphic objects connection point. This one is not an energy connector. And it is a input port. We set the type using this property. This means that this port is a inlet port, inlet connector. And its position, we can set it to a new. It is better to set the X and Y. So the X, we can set it to the initial coordinate of our object, which is X, plus the graphic object width height divided by
3?
3, yes.
Okay.
So we can put them equally spaced. And since we don't have any port, we will add this. Oh, I forgot to set the name of the port. Connector name, we can put it at gas in that port. Gas stream. Add. So now we are going to add this port too. I'm going to use the same code to add the second port. This will be the water stream. And this is the X.
2 by 3 or something.
Yeah. Since we are going, this port is located at the beginning, the Y coordinate is just is the same Y coordinate of our object. Did you see how what I was going to do? I was going to let it port 1. I do this a lot. Now we are going to the outlet port.
The outlet?
Yes. No, but yeah, we could either create a new if to check if the outlet port collection is 0, but since we are going to add them at the same time, but I think it is better to check it just for the sake of simplicity.
Only one.
Yeah, port 3. This is a outlet port, and the X will be divided by 2 because it will be located in the half
Middle.
Yeah. And the Y, since it will be located in the other end of the object, we need to sum the Y with the width. Yes. And we can mix it stream outlet port. And be careful to change it to the output connectors. Okay, this is just in case we didn't add the ports yet, because this routine will be called every time the flow sheet gets drawn. So if we don't have any port, we will add the ports here. But what if we have the ports already? We must just update the coordinates of the port. We don't need to change anything else. Otherwise, it will be, the port itself will be located in the first point that we added the object to the flow sheet, and after we move the object, the port will stay in that previous location. Yes, that's why we must change we can just reference the port by its index. Here. The first port has a 0 index. And the second one has a 1 index. And okay. Same here for the output. Okay, this is enough, I think. Let me build. Let me see if we everything is a bit failed. Oh, SK image is not applied. So that's right. Okay, I think we can try it again. Yes, succeed. So now I'm going to try to add this unit operation to the DWSIM just to see if it is drawing correctly and the ports are positioned correctly. I'm going to open the solution folder here so we can locate the DLL. It will be since we are compiling it with the debug configuration, we will find it on bin debug. So you can see that it copied a lot of DLL here. I'm not sure why, but we only need these 3. I'm going to copy it and put it into my DWSIM installation folder. I think I'm going to add yes, because we will do this a lot. So here in the DWSIM installation folder, you will find a folder called unitops. This is where you put the new library. Okay. Now I'm going to close the DWSIM and open it again. Oh, I forgot to set the type of the unit operation. We can change the type of it, the unit operation, by telling public overrides object class. The type of our unit operation, we can
Just for grouping?
Yes, I think I'm going to classify it as a mixer, just to just for grouping. Otherwise, it would be considered to be a user model.
Yeah.
Hi, Mohammed. How you doing? Okay, so I'm going to open the DWSIM. I'm going to open a random simulation just to see if our object displays correct. Yes, here it is. See, this is the description that we added before. Then I can drag it to here. See, our code is working correctly. The prefix is okay. But since since we didn't create the editor window yet, we don't see anything when we click on it.
Yeah, but the connectors should work.
Yes, the connection should be okay, but we don't have the editor yet, so we can't see anything. So I'm going to try to connect it to. No, it didn't work. And we have an error. It didn't work. Connect to. Yes. It isn't working. Let me see if I forgot something. I'm going to debug. Oops. Sorry, guys. I don't know. I'm going to debug to see if we did anything wrong. Strange. Okay. 1 second.
Okay, let's see if the output connector is working, bros.
Yeah, it is throwing the same error. Let me see if I can find the line in the WSIM. So we can understand what is going on. position. I think I know what it is. Instead of setting the X and Y property, you must set the position of the part. Then this point asks for the X and Y. Yeah. I know this is silly, but I'm going to fix this in the next. Comes to 30. Okay, I think this should work.
You've compiled the file first?
Yes, I click here and build.
Ah, yeah.
Okay, now, yeah, but the coordinates are not quite there. I think we need to fix something. Where is
Okay,
it?
and
Where
now-
is this X? I don't know. No,
No.
no. I think it didn't quite work at this point. What I did wrong? What did I do wrong? Okay, part one position X plus no. This is X and Y plus height. I was summing the X with the height. I did this on purpose so you can. Just to see if you are paying attention. God. No, I'm not teaching. And this one is X plus width and Y. Yes, X plus width and Y plus height.
Right.
Height divided by 2. Okay.
Hopefully our egg now has some inputs and outputs.
Yeah. Agora.
Ah,
Now it is. Yes. Okay.
yes, that's good.
Now we can proceed to the actual model. I think we don't need to create the editors yet. Let's move on to the actual model.
Yeah.
It is better. Okay. So where is the routine? We need to override the routine to do the calculation. We must type public overrides calculate. If we do not override this routine, it does nothing. It works like a dummy operation. But we need to mix the water stream with the gas stream. And this mixed stream will be passed to the outlet, through the outlet port to the outlet stream. So how can we get the inlet stream connected to the first port? Let's add a import so we can, I'm going to add an import here so we can get some auxiliary functions from this library called DWSIM extension methods, okay? So we can get the gas stream. I'm going to name it as gas. That is the gas stream back. So we can get in get. I don't know. I think it is not in the extension method. I think it is in shadow classes. Let me check where this function is located. Just 1 minute. I don't remember. Yes. Get outside base. Okay. It is No, it is working. Yeah. So this function gets the material stream connected to the first port, which has a 0 unit. So we have the first material stream here, a reference to it. And the water stream, we have here. And initially we are going to consider these humidifiers as adiabatic, okay? So we will, just a minute, I'm going to change my chair. Okay, so we need to mix these two streams together, and we can do it in an easy way or in a hard way. So the easiest way is to use a helper function, which is inside the material stream itself, which is add. So we are adding the. Actually, we need to clone this stream first, because otherwise I would be changing the gas stream itself, the inlet stream, and this is not allowed. So we can create a new mixed stream equal to gas stream clone, a clone of our gas stream, and then we going to mix the stream. Thermodynamics. The material stream is located in the thermodynamics library. Okay. So mixed stream dot add, and then we add the water stream. Just for safety, we will clone this stream so we do not mess with the water stream itself. And we set the mixed stream equal to itself. Mixed stream equal to itself plus the water stream. The pressure of this stream, we must set it. First, we will get the pressure of the water stream, the gas stream. P gas equal to gas stream, get pressure. This comes in Pascal, in the water equal to water stream, get pressure in Pascal, and then we set the pressure of our mixed stream to P gas, P water, also we set, since when we do the add, the DWSIM already copies the compositions and the flows, everything that we have on the second stream to the first stream. So we are just setting the other properties that are specific to this kind of problem, which is the pressure and the enthalpy, because since this is a adiabatic humidifier, we need to calculate the outlet temperature using a property package. The property package which is associated with the humidifier. So we must set the pressure and the enthalpy of this stream.
Yeah,
Okay.
I thought you will just add the component water. The add function will auto calculate the new mole fractions of each component.
No, it just adds it just sums the flows and the compositions, and it does set the enthalpy and the temperature, but since we are not sure how it does, it is better for us to set them manually, just to make sure that
calculate it.
okay. Just to make sure that we are doing it right.
Okay.
What we are doing is we have our humidifier here, and we have the streams here, and we have Pg, the enthalpy of the gas, the pressure of the water, sorry. And the enthalpy of the water. And the outlet stream, we have a Px, which we are defining as the sum, the average of the streams. And the enthalpy of the outlet, since this is a adiabatic humidifier, the outlet enthalpy will be the sum of the two enthalpies averaged by the
enthalpy, you mean? Enthalpy?
Yes. And this will be the mass flow of the gas times the enthalpy of the gas plus the mass flow of the water plus the enthalpy of the water divided by the sum of the mass flows. Okay?
Okay.
So we have here, let's get the enthalpy of the gas. Gas stream, get mass enthalpy. This enthalpy comes in kilojoules per kilogram. The enthalpy of the water, so that's stream,
You will pass the enthalpy and the pressure to the fluid package so that it brings you the temperature?
Yes, it is important to have the same property package here. We can add some safety routines later to check if the property packages are the same, if the water stream is actually water. I'm going to show you how to do this later, just to make sure that the user will not do anything stupid. Because that's what we actually do. Get mass flow. This one comes in kilograms per second. Sorry. Okay, so the outlet entropy will be AG times
You'll need brackets also. Yeah.
Okay, this one is in kilojoules. And now we set the mixing stream, set mass entropy to HO. We also set the flash calculation mode for our mixing stream to be set flash stack to pH. So the DWSIM will use the pressure and the enthalpy to calculate everything else, including the temperature. Okay, so now we can get a reference to the outlet stream. equals to get outlet. I don't know why this function is not being recognized. And then we assign the properties from the mixer stream to the outlet stream. And the DWSIM will do the rest. This is the end of this procedure, and then when the flowsheet goes to calculate the outlet stream, it will have the pressure, the enthalpy, the composition, and it will calculate the temperature. We don't need to calculate it here, but we will do this later just to check the saturation temperature and stuff. But we don't have to do it here. The DWSIM will calculate it when it goes to the outlet stream and calculates it. Okay, so let's see if we are doing this correctly. I'm going to debug this calculation line by line so we can see.
Let's be optimistic.
Yeah, it never works in the first time, so let's hope for how do we say, let's hope for the worst, work for the best, something like that.
Hope for the best.
Yeah. Okay.
You know that I'm feeling lucky in Google. Yeah.
Yeah. Okay. I think we will need to create a new simulation first. If you downloaded the material that I put the link up, I'm going to put it again so you can. The link is here on the chat of the meeting. You can download the material from here. I scanned my book where you have a introductory text for the humidifier. And we have a example here that we can reproduce. We have flue gas at 32.0 Fahrenheit. We have CO2, water, oxygen, nitrogen. That's carbon dioxide, water, nitrogen, oxygen. I'm going to use Rhodes law. I always like to save them. Simulation. I'm going to save it into the folder I sent the link to you. Yes, so you can. This will be our gas stream. I'm going to attach Visual Studio to the DWSIM so we will debug our calculation directly. I think it didn't update the code. So I'm going to try again. I'm going to close it. When this happens, you can go back to the solution and rebuild. So it will be compiling it from scratch. Oh, it failed. Not specified. Something is not. Oh, oh, he's saying that the public function is not accessible in this context because it is public. We have something that is not public here. Public or public class. I'm not seeing anything.
Maybe it was the function that was not registered that you typed it wrong.
Yeah, I'm not sure because this function is public. Our class is public. It is here. Unit operations. It is here.
Yeah, this one. Yeah.
Mm-hmm. Yeah, it is not.
No, still yeah.
Frame module. This is strange, but we have another way of getting there. I'm going to write something really big here, but flowsheet get simulation object. Flowsheet simulation objects. And then we will get object, attach it. We are going to access this stream using the connector.
Yeah, but this is which stream? I mean, like this, you will not be able to link to the guest stream itself.
No, I will because I have the port is connected to that line, which is a connector. The line it is an object, and if the line is connected, we will have this property attached connector attached from, and this is the string, the graphic object, and the name of the graphic object is the same as the string itself. So we can access the material stream from its name and get it from the simulation object collection here.
Yeah.
It should be easier to use this function, but I don't know why it isn't work. Maybe if I use it as a function itself, not a extension. I'm not sure. Humidifier cannot be converted to unitop. What the? I'm not sure if we are missing a serializer. not that. I don't know why. This error normally happens when your class is not public, but we are defining our class as public. Maybe it is the namespace. I'm going to put it into a namespace, public namespace.
Okay.
Oh my god, I remember what I did wrong. It is not the unit operations base class.
Really?
It is yeah, it is the unit operation unit op base class. That's it. But we don't need to do it, again. It is almost the same, but with a few. I don't think it adds anything else. Just yes, it doesn't add anything special. Just I need to rebuild it. Yes, unit of base class. Yeah, it was not. Yeah, they should be working. Let's try the other.
Okay.
The outlet connector is connected to. We must change it to attached to.
Yeah.
Then we go to
output connectors, not input.
Yeah. Yeah, this is for the outlet stream.
No. The previous
Yeah,
line.
okay. Out. Okay, thank you. This is so okay. Something's missing. Okay, there is something wrong with it. But let's see, we can add a new one.
Our egg isn't here. Mixer.
No, it is, but there is something wrong with it. We can check it.
I think because we changed the
Yeah,
unit base.
yeah, something in there.
Yeah.
We can look at it later.
Next.
This should work. Ready for a bunch of errors. Oh, okay, let's list it. So fresh. Okay, so we have I1. We have the ID of the material stream. You can see that the connector is attached to a stream here. And we get the name of the stream, and we can use the simulation objects to collection to get the gas. Yeah. And then we I2 also has a reference to water. Okay, everything is okay so far. The mixed stream is a clone of the gas stream.
Yeah.
Okay. Now we have,
and then water is added.
We have water stream, we have 1 kilogram, and mixed stream, we have 2. So gas has 1 kilogram, water stream 1. Okay, everything is okay. And now mixed stream is with 2. And we can check it. The compose. Oh, I didn't change the composition of the stream, but the calculation.
Yeah, I asked you about this, and you told me that.
No, I forgot.
We do it itself.
I forgot. I'm sorry. Just let us check if the calculation is going as expected, then we can change the composition. Okay, the pressures are being read as expected. The enthalpy of the gas, enthalpy of the. They are the same. They shouldn't be the same. No, they are the same because the composition is the same. Okay.
Yeah.
Okay, this should be the same because everything is the same. Mixed stream, outlet. We get the reference to the outlet stream, and we assign the outlet stream to Mixed stream. Okay. So, okay, but let's change the composition to the actual sample. Are you seeing the PDF?
Yeah, we can see it. Yeah.
Okay, so we have CO2 14, 736, 76. Okay.
But this is molar flow rate, I think.
Yeah, molar flow rate, but after we normalize it,
Yeah.
it will be.
Okay.
We don't need 1473. 76. Water.
Okay, let's get the temperature and pressure from the PDF.
Sorry?
Okay. The temperature and pressure from the PDF.
I didn't understand. Can you speak a little slowly?
The temperature and pressure from the PDF.
Mm-hmm. The temperature of the flue gas to 305, 320. Oh, I think I set the wrong. And the water is 80, I think it's 85. Okay, the result should be something. This example is just a mixer, and it's saying that it is adiabatic. I try to say adiabatic. And the outlet temperature, the base is 100 mole of gas. It doesn't say the amount of water. But let's check if it is calculating the composition of the mixture. Okay.
Yeah, beautiful.
Yeah, and the outlet temperature should be about 120 Fahrenheit. Yeah, not quite. Let me check.
You can change the flow rate.
Yeah, we need to add more water because everything went to the vapor phase. It is not saturated. Let's add a lot of water. That's something we can check into the calculation. We can check if we need more water or not.
Yeah. Until no vapor, yeah?
Mm-hmm.
Until liquid phase appears.
Yeah. Yeah, we still need water. I have a problem with these tooltips. I need to fix this. Sometimes when you put the cursor here, this tooltip doesn't vanish. It is still, it remains here. Yeah, I think you already noticed it. I need to fix this. Okay, so here we go.
Some cosmetics.
Mm-hmm. Yeah, I think we Yeah, quite close to 120 Fahrenheit. Okay, I think it is working.
Sorry, one particular question is in here is, why are you feeding water? Instead, why can't you just set on the unit operation itself as what is the required relative humidity, and it should calculate automatically the amount of water required to attain that particular relative humidity in
Yeah,
the outputs.
we can do that, but it is a little more complicated, but we can do it into the calculation procedure. But
it will be like a saturator.
Yeah,
Exactly.
Yeah, exactly. Yeah, we can do the same, but I think it will take too long, and we will miss the what we. I think after we finish, you will be able to do this for yourself if you want to.
Yeah.
Because it would take too long to implement these calculations, and because we still need to implement the editor, and I want to show you how to make it isothermic, and I add a selector in the editor to change the calculation mode. We will need to add a energy stream if we are going to do a isothermal calculation. So I'm going to show you how to do it now. But first I need to fix the humidifier not showing when we load the simulation. I'm not sure why it didn't finish. Let me check if there is something wrong. No, of course there is something wrong, but let me try to find it. Return new humidifier. We forgot to add a few functions here. I'm not sure if this is the error. I'm going to try to debug it here. When the flowsheet is loaded, the DWSIM calls this function to return a new object to the flowsheet. So I'm going to see if it's working correctly. It isn't even calling these functions. Okay, one thing I forgot to show you is if we open the cross-platform user interface. You will be able to see the name of the connectors here. Remember that we set the name of the connectors here. But what is this? I think it is the energy connector, yes. The energy. Every unit operation that we create has a energy connector, which you can leave it active or not. In this case, we will not use this connector because it is somewhat problematic, and I'm not using it anymore. I prefer to create a new port of the energy type. That's what we are going to do here. We are going to add we're going to create a new property. I'm going to debug that issue with the object not being loaded correctly, but let's proceed to our calculation model. I'm going to add a new property here. Is adiabatic. That's a bool to tell if the calculation mode is adiabatic or not. Okay. If we are going to the isothermic route, we need an energy stream to close the energy balance. So we can add a new outlet port here. This port.
Let's say the height and half the width.
This is a energy connector. I don't know why but we have to set it here too. I know this doesn't make sense, but this property, I think it was added 1,000 years ago, and this one is more recent. So the coordinate of this port will be x. We will put it in the bottom of the humidifier, just like the power cord. Y plus height. Okay. And this is the
Energy stream.
Yeah. And we must set its position to okay, so how we are going to proceed here? We need to check if the we need to assume some things. Is this operation going to work if we have the inlet streams with different temperatures? What do you think? In isothermal mode, or we can set it to maybe isothermal mode means that the gas temperature will not change. What do you think? I honestly don't know. We can do anything. I don't know if this is physically.
I think it will work because
yeah.
Because the enthalpy the H node like line 227 will work either way, even if you change it.
Yeah, but in this case, we will need to. We will need to put a if here. If is adiabatic, then else. The procedure will be different here. Okay, adiabatic is this procedure, and isothermic mode means outlet temperature equal to gas temperature. So we must get the gas temperature. Gas temperature.
Yeah, but how you will get this input from the user?
Get what?
This input from the user, like if he wants to make it adiabatic.
We will need to implement the editor.
Okay, so we'll force it in the code, yeah?
I need to explicitly tell that this is a material stream to get its properties. Comes in Kelvin. And now we set the mixed stream set temperature to Tg and mix it. In this case, the DWSIM will need to calculate a temperature pressure flash. So temperature set flash stack ET. Yes, someone is trying to pressure, and this one is pressure. But how do we calculate the energy balance here? We need to calculate the stream. So we will need to get the entropy of the outlet stream. So what we will do is the following. We will use the property package of this unit operation and set the current material stream to the mixed stream. And then we can go and call the calculate function of the material stream. And then we get the outlet entropy of the mixed stream. Get minus entropy. And we will need the mass flow of the outlet entropy too to calculate the mass and energy balance. Okay. What will be the value of the energy balance? Kilogram per second. Kilogram per kilogram. Okay, the energy balance will be W times HO minus WG. I think I need to. We need these properties on the
outside the if.
Yeah. 10 years ago, I would be copying these lines to the other else, but now I'm a little smarter, and then I'm going to put it on the outside of the no, this is basic chemical engineering. I think this is what our students need to learn, how to a process simulator works is exactly the same as we learn in the books. Even in the distillation column, we have thousands of equations, but they all reduces to something like this. And this will be in kilojoules per second, which is kilowatts. And how do we get the outlet energy stream? We will do the same here. But since since we don't need an energy stream in adiabatic mode, we don't need to always check if there is an energy stream connected to it. So we can get the energy stream just in this specific case. The energy stream class is located in the unit operations library. And then we set the energy flow property of the energy stream. Flow through kilowatts. Okay. Now let's compile it. We need to create the editor just to, so we're able to change the calculation mode. I'm going to add a new form, Windows Forms here. And call it editor.
Just a selector?
Yeah, but we need to create a form. And we will need to change this form to, I did a double click here, okay, to enter this one. We need to change the type of the window to a docking window doc content. So it becomes dockable like the other windows. And here we need to implement a function called updateInfo. If we have a table with some values for some parameters, we will need to update these parameters in the form inside this function here. We need to add a property here, which is object as humidifier. This one will be a reference to our humidifier. Okay. We can set, upon the loading of the form, we can set the text of it to the age object. The name of the object in the flowsheet is stored in this property, graphicObject.tag. because the name property is the unique ID of the object. It is that one which has a lot of numbers and letters. And then we call update info. And now we are going to
combo box or something?
Yeah. Do something really simple just for you to see how it works. I'm going to do calculation mode. We will change this combo box to a drop-down box, drop-down list, and then we put it here at the level and Okay. And then on update info we check if page object is available, then combo box 1 selected index is 0.
Let's make a default selection so that it does not hang when the user just run the file.
But every time the form opens, it will run this and check if what is the value of is a diabetic, and then select the proper item. We are setting the is a diabetic to true here, so the default calculation mode will always be a diabetic. Okay. So we need now to create a variable for our form. And now we are going to display our window. If edit window is not, then we create a new one. We can put a new editor with page object equals to me. Do you understand what I did here? Yes, no, maybe. I'm creating a new window with the age object property equals to this.
Yeah, but I didn't choose this.
I'm setting a reference to the age object so I can read its properties when the form is created, and I can edit the object in this form because this object is the same as the one that is in the flowsheet. So I think this is enough. And then since this is asking to display the form, I just go to edit. I think to flowsheet. All unit operation has a reference to the flowsheet, this variable flowsheet. So I can call it display form. I must also check if the form was already disposed. If it is disposed, I must create a new one. Then this one calls the update function. It is called by the DWSIM to update the editor after the flowsheet source. So we can just put edit window update info, which is going to call this function here, and close edit form. If we put, just for safety, a question mark checks if this is actually something. Otherwise, it will not throw an error if this window doesn't exist.
I didn't know this trick yet.
Yeah, it is really nice. I learned it a year ago. I'm using it all the time. Close. We are going just to call the close function. Okay, I think this is enough. Build failed, as expected. Okay, I must change the editor designer here. I must remove this line here from the editor. Let's try it. I'm going to put some debug stops. You can see that in the other editors, in the other unit operations, I always put the connection stuff here, the ports, but it is a really boring logic, so I'm not going to put it here because you can connect using the drop-down menu in the flowsheet, but when we are going, if we are going to do something really serious, we must put the controls here to edit the connections of the object, but I'm not going to do this today because it's really boring. I don't like it. And we don't need it here. Oh, I don't know why it isn't loading. Let's add another one. No. Oh, no. That's right. I need to change the... I need to change the edit window. What is the property? We must change the default display mode of this form. Yes, show hint. Yeah, show hint to dock left. I'm going to add the energy swing. Okay, everything working as expected. Actually, I didn't trigger the flowsheet solver when we changed the property here. I needed to do that, but let's just check it Cross operation not valid. Yeah, we need to fix something here. I'm going to call the flowsheet solver in this event of the select when we change the index, the selected index of the combo box. Flowsheet request calculation. So we request a flowsheet calculation after we change the calculation mode. And here I need to change this to add window. I need to check if this is when you call the something that reads a property from a object in the user interface from another thread, and it doesn't like it because it can freeze your program. So we need to take some care to not to do this. Okay. And now let's see if it is calculating the isothermal mode correctly. You can see that the flowsheet calls the calculate procedure here. As soon as we change the property here, then it shouldn't be adiabatic. Should be isothermal. Something is not. I need to. I forgot to actually change the value of the property here. In that case, on the box select case 0. We could do this in a number of different ways, but I'm doing it like this because it is easier to understand. Okay, now. Are you still there?
Yep, we are.
Okay.
Yeah, that's perfect.
Okay, so now we are going to the isotopic. Yeah,
Now we are grateful for your work.
Yeah.
in DWSIM. This is the normal day.
Okay, so now we have the temperature of the gas stream, and we asked the WSIM to calculate the stream so we can get the updated entropy of the outlet stream. Then we have a value for the energy stream, which closes the energy balance of our unit operation.
Yeah, it will be always positive or
Sorry?
it will be always positive value?
Yeah, we must take some care here because we have the energy stream connected to the outlet of the unit operation. I'm not sure if this is a correct form of the energy balance. What do you think? Get the outlets minus the inlets, and then no, it should be the opposite because the energy, the correct form is EB plus W EO, yeah, and then EB is the correct form is the inlets minus the outlet because the energy. Yeah. Not sure. Yeah, this will not work. We must compile them. So I need to close.
You lost your egg again.
Ooh, I opened the wrong. Oh, it is a diagram. It is still positive. Yeah, because we have. No, I did it wrong. Oh my god. It is W minus W. Yeah, this is the code. There is nothing new here, guys. I do this all the time. Don't worry. I'm not nervous or anything. This is just my normal way of doing things in DWSIM. I do it like 100 times.
HW is negative.
Yeah, the outlet's positive. I believe it. I think this is correct. It's just the actual values of the entropy.
Yeah.
Yeah, we must check the energy flow. 929, 409, minus 4,
Yeah, that's why. Okay.
Perhaps this should be negative. I don't know. Yeah, but the routine is working. We need to fix this later, but I think it is working. Okay, so I'm going to fix this loading issue, and I will upload the solution to my GitHub.
Okay.
So you can get it later and compile it and check it for yourselves. Okay?
Yeah.
Because this already took too long. I'm thinking you are tired and I'm tired too. It should be something really...
Thank you, Daniel.
Okay, so I'm going to put the link for the solution on GitHub, so you can access it later. I hope you guys understood how to do it.
Yes, okay. It has been very helpful.
Yep.
It's not... I think that it is not too much complicated. The only thing that makes it a little complicated is the drawing part itself and the editor, but it is something that we need. We can't do it without these little things.
Yeah, maybe even some part of the drawing can be integrated in the DWSIM itself, like when you create a new unit operation.
Yes.
And you move the unit operation, it automatically moves the connectors and so on.
Yes.
But everything else is good, I think. Yeah.
Okay, guys. So next week, I think we will do a property package. What do you think?
Sure. Daniel, would you consider showing us how to add isotopic properties as well? Because this is something of which I am struggling with, because like, for example, we have a different isotopes of hydrogen. They have the same chemical formula, but different thermodynamic and transport properties. So I just want to know how to create them, firstly using compound visit in DWSIM, and how to call them in the main program. And I can forward you by email the supporting data which you may need, for example, to create compounds, which may include like the critical constants, eccentric factor, boiling points, etc. So that you can create a pure compound like they're doing SPEM plus. So that would be very useful for everyone, in fact.
Okay. So if you send me the data, I can create a video. It doesn't need to be a live presentation. I can create a video and I will let you know when it is ready, showing you how to add these properties and create a new compound. But I can only do it if you send me the data, because I don't have the data for the isotopes. And I don't think it will be available through the online sources that the DWSIM can connect to.
Yeah, I can send you on your email. That's no problem.
Yeah.
And then I think what I am also interested is all the good work you have been doing to support the industry and other users, and giving them access to such a valuable tool so that they can develop. the idea is we help each other and make sure that everybody learns from each other.
Okay. Okay, thank you.
Thank you, Daniel.
Do you guys have anything else to add or suggestions for the next session? Do you think that Google Meet is okay for these sections?
Yeah, I think
Yes, I think it's perfect.
I think it's better than Teams actually.
Yeah, I'm thinking about the next session. We create a property package using the Wilson activity coefficient model because the DWSIM doesn't have it. And I think it is simple to do. I'm not sure if you agree, but we could do it to a mixture of water and ethanol only just to see if it will work correctly. I think we could do it in a few hours. What do you think?
Sure, that would be useful.
Yeah, because the property package is really important for the DWSIM, and that's where the actual thermodynamics comes from. It is very easy. It is something really different when compared to unit operations. It's a totally different part of a process simulator. I think it is important for you to understand how it works and how to do it. It is much more mathematics and stuff than interface. We don't need to do any window and drawing. It's just math, and
yeah, that would be interesting. By the way, the unit operation you created today, are you gonna add that in the upcoming edition of?
Yeah, I'm going to add some functionality like checking the water stream, and I'm going to finish the editor and check the other thing that needs to be checked, like the other unit operations. But I'm going to upload to our GitHub, and you can download it and compile it for yourself. But it is going to be part of the DWSIM, yes.
Yeah, that would be great.
Yeah.
In fact, like as I mentioned earlier, if you get a chance, then it's not, the saturated is not very different than the fire. So considering that, like it would be helpful for new engineers as well.
Yeah, we can add a new calculation mode, like saturator, and do the calculations accordingly. We have a Python script to do it, but I think it is not.
I mean, like create it as a unit operation within the DWSIM, so that everybody do not really need to write their own script.
When I created that script, it was just to show the Python functionality. It was not actually about the saturator itself. It was just to show how you can create your own unit operation using Python. But since now we are working with the actual unit operation, I can increase and implement new stuff to this one, so we can get a full saturator working. Okay?
Yeah, that would be great.
I'm going to do it during this week, and it should be available in DWSIM 6.4.6. Yeah, the next one is 0.6. But let's wait for a week or 2 weeks. Okay, guys?
Thank you so much. Appreciate it.
Okay, thank you.
Daniel, I have a question for you. Regarding the distillation curves interconversion, when you use you input the distillation NSI, you input the distillation curve, then you make the pseudo cut point, everything is okay, and then when you collect the property of the stream, I cannot see any calculation back to the distillation curve. That is not implemented, isn't it?
No, not yet. But I know that is something that high seas have, and it would be nice to have.
It's something that it's something that can be done using the API. data book, technical data book correlations. Do you have any plan to introduce that? Or
Yeah,
can
we have.
anybody of us can
Can
help?
you can add this as a feature request, and then I will work on it.
Yeah, I already wrote it down.
Yeah,
I don't know if you have seen it.
I remember. Yes, but please create
do
a
you think,
new.
Do you think can be implemented as a utility? In one of your videos, you may show us how to do a preliminary utility for the DWSIM, and then we can work on coding the prototype, the utility. I don't know if we can work together doing that, but at least to have a video introducing how to do an utility calculation package.
Yeah, we can do that later. After the proper package, I can teach you how to create a utility, a plugin.
Yeah, it's wonderful. Wonderful.
Yeah, we have a lot of time. I think we are going to do these live sessions every Saturday, if everything goes well.
Yeah, it would be nice.
Because I have a room in my house for it. I didn't have before. So now I do. I think it is easier for us to talk without being interrupted.
Yeah.
Okay.
Okay.
Okay, guys. Thank you very much. I see you next Saturday. Okay. Bye bye.
Okay.
Take care.
At the same time, Daniel. At the same time. At the same time.
I think yes. I think it will be at the same time because it's after lunch here in Manaus. It's 1 p.m. It is okay for me because I can do it during the week because when it is late night here in Manaus, it is very, very late in Europe and India and the other countries. I think, and I would be more tired. Yeah, doing this at night, it would be more tired. I think Saturday is perfect for us too. And this will be recorded and added to the YouTube channel, and so you can always check this video later at any time you find better. Okay.
Okay, thank you, Daniel.
Okay, thank you.
Thank you. Bye-bye.
Appreciate you.
Bye, guys. See you next time. Take care.
Okay, bye.